Hello, welcome back to our channel. My name is Nigel and this is Offgrid Van Life, where we look at Offgrid Power, van conversions, lithium iron phosphate batteries and everything in between. So in this video, I'm going to be looking at building out from scratch a lithium iron phosphate DIY battery and specifically using the Daly BMS. So in this video, I'm going to be looking at how do I actually build out a battery so that I have one of the best value for money systems in my van or off-grid solution. So let's get after it. So one of the first things that I do with a set of lithium iron phosphate cells like this is that I put some sort of box or compression system around it. So there are a number of ways that you can do that, and we've spoken about that on most of our social media and on YouTube and that fairly extensively. You can do it just with some tape, so non-flexible tape. You can buy various tapes like that, fiber tape for example, that sort of thing. Or you can use other methods. One of my favorite ways is actually to use a couple of pieces of plywood on either side and to then use a bit of threaded bar like this, just with a couple of nuts. And I don't pull it excessively tight, so I'm not tightening it so much that it's deforming the cells or anything like that, but I'm tightening it to the point where it holds the cells in place so they can't move around, can't shuffle around. But most importantly, as you're charging and discharging, the components inside the cells are not moving and delaminating or anything like that, which obviously then will lead to a decreased lifespan of the cells. So the first thing that I'm going to do is to measure out 4 pieces of this threaded bar, cut it up, grind the edges nicely so that they're nice and rounded, and so the threads work again, all that sort of stuff. So one of the things that I do when I use these threaded bars is just to get a bit of basic pipe like this, and I'll cut 4 lengths and then put the threaded bar inside the pipe. That way when your threaded bar is alongside the battery cells like that, I always leave enough space so that it's never in contact, but just on the off chance that something happens and the cells shift slightly in the case that I build, if they do happen to contact, then they're not wearing on this threaded bar, then they're hitting the plastic pipe. Right, so I've got my 2 pieces of plywood. They're just stock standard 18mm plywood, just whatever you get at your hardware store type thing, nothing fancy about it. And I just spray painted just with Hammerite spray paint, so this sort of stuff. This is obviously white, but I just use a black one like that, and I just spray paint it just because it looks a bit nicer, kind of protects the wood a little bit, and just gives it a nice finish. You'll see when it's all done. But now I'm just going to drill my holes. So for the bottom 2, I am not going to even measure them, just because I know just by experience and eyeballing it that if I get it fairly close to the edge, will be good on those. Okay, so that's that one done. And this one should be the same sort of distance. Okay. Put it up against here. Sweet, perfect. And then the top ones, in. Pencil. Okay, so I've got those two boards drilled out like that. So I'm going to put them on these spaces here that you can see just below. They're mainly because this battery, when it is installed, it's going to be dropped into a little tray that has an inset that they're going to be sitting in. So now I am going to put these pipes onto the threaded bars and get everything put together. So the way that I've configured the cells in terms of how they're sitting here is actually in series, even though I haven't top balanced them. And the main reason for that is that there's no point in top balancing your batteries and charging them to then only go and compress them, because as soon as you start top balancing them, if they're going to move or if the components inside are going to do anything, it's going to be whilst they're charging or discharging. So if you are interested in compressing them before you top balance them or anything like that, then if you're going to compress them, put it this way, if you're going to compress them, then you need to do it before you actually top balance them, otherwise there's no point in doing it at all. I like to compress them just because they will last slightly longer. There's been various studies that have shown that if you compress the cells, there's a greater likelihood that they will have a longer lifespan and you'll get more cycles out of them. Okay. And as I mentioned, when you're tightening these, you're not looking to compress the cells so much that you are disforming them. You're literally tightening it enough to hold them all together, and if there does happen to be any movement in the cells, then this method will stop the cells from expanding or contracting and moving. And just before you get them kind of tightened, you want to be just checking, making sure that you have them all lined up and straight. Okay, so that is this battery top balanced now. So now we're going to go ahead and put the BMS on. But one of the things that I like doing when I make these DIY batteries is I take a bit of 9mm ply. So this is 18mm ply that I've got on either side there, and I then just screw a couple of pieces of 9mm ply on either side of the clamp like that. And that just gives you a nice surface. Firstly, it protects your cells by boxing them in, but secondly, it just gives you a nice surface to be able to attach things. So I then like to put my BMS on the outside there, and you can also screw fuses, or if you have a shunt like a Juntec or a Victron Smart Shunt or something like that to measure, it gives you a nice surface to be able to work with to attach things onto the side of the battery. So we're going to get that on, and then we'll get the BMS installed. So I'm going to turn this around so that you guys can see me do that from the side here. So let's get after it. What I then do is take a big hole cutting drill bit like that one, and I'll drill a hole into the side next to where my cables are going to come out by the terminals. Because essentially what you are doing is we're going to be mounting the BMS probably like that, and this cable needs to be able to wrap around, go through the hole like that, and then get onto the terminal. So essentially we want a hole that it can go pretty much level with the terminal like that. So okay, so we're going to get on and mount this BMS. So with the Daly Smart BMS, what you get in the box is a temperature probe, a Bluetooth dongle, and your balance leads. So the balance leads come just with nothing on the end here. I like to put these type of connector lugs on the end. So these are the ones that have the heat shrink insulation. They do a really neat job. And so I've got those prepared here. We're going to mount the BMS something along like that with this cable, your B minus going here to your negative terminal on your battery, and this we will probably put around to this side here to a bus bar or something along those lines that we can then connect from there going out. Then obviously the positive line from the battery is going to come from here. And then we'll do something else in here as well, where we will mount a little switch that I like to use for these batteries as well, which is this little guy here. And so that enables us to just turn the BMS on. So with this Daly BMS, you have to short those 2 pins in that there. So on the bottom here where it says monitor, in order to turn it on. So when you just connect this up, when you test the voltage on the BMS, it'll just say something like 3.2, 3.3 volts, somewhere around that. Basically the reading of whatever an individual cell is, but you have to short these 2 pins in the second one behind monitor, where there's just nothing labeled on that plug in the bottom there. You have to short those 2 pins, and that turns the BMS on, activates it. And so essentially what we do is we wire one of these in. We've got those and the little plug for that. We'll link all of this in the description down below, but when you wire this in, that basically does that job of shorting those for you. Okay, we are now ready to install the Daly BMS. We've drilled out our holes. I've created a little bracket here that will be used for this on switch. So that's the little on switch there. I've just extended the on switch, so these plugs and the on switch itself I just buy on Amazon separately, so I've just extended that with a little bit of wire there. So we're going to put this Daly BMS on here and get it all up and running. So put it probably about there. Well, actually, it doesn't matter too much whether it's in the middle or not, because you can always just okay, so that's that. So we're gonna now feed this B minus cable, which goes to your battery terminal, through the hole that we made there, and it should be able to reach the terminal, which it does, and we can maneuver that to be able to tighten that down, which is good. So yeah, looking pretty good for that. All right, so now we are going to connect this battery up in series so that we can create a 12-volt battery to use on our system. So obviously when you're doing this, when you're working with terminals, you need to be wearing safety glasses. I wear specs all the time, so I'm happy with that. But yeah, and the trick here is to make sure you don't short anything, because that would not be good. Okay, so we get our bus bars in. The bus bars that come with these Catel cells are actually quite nice because they are the flexible kind, so they are tinned copper. Next I'm going to put in our balance leads. So I'm going to put the balance leads in through this hole here. Am I? Or will I go the other way? Let's try the other way actually. Just see. Okay, so when you're connecting this battery up, it's important to connect up all of your cables for your balance leads before you actually plug them in. So that's what I'm doing here. I'm just going to hand tighten all of the nuts onto all of the balance leads onto the bus bars, and then obviously you need to get the sequence of these, the sequence of the balance cables correct when you are doing this. So actually what I'm going to do is, rather than putting them all through, I'm going to pass them through one at a time to make sure that I get the sequence correct for the different cells, because it has to be the correct configuration. So this is going to be the positive on B1, and then you just go through, put them all through the hole, put them on the correct terminal. So we won't be actually plugging the balance cable in yet because we haven't got everything else done on this battery so far. So we're going to finish up putting all of the nuts onto all of the bus bars here, and then we can torque them all down. So these Catel cells, the manufacturer recommends that you torque them to 9 Newton meters. It seems like quite a lot to me, so I'm actually going to torque them to 7 Newton meters. I'm happy with 7. So this can be a bit tricky because your actual battery itself will want to move around and your terminals will want to spin around as you're torquing them. So obviously make sure that you watch for the click of your torque wrench, because some of these smaller torque wrenches, it's easy to miss and you can land up. Okay, those are all torqued now, in good shape. Next up, let's turn this on its side. Oh, actually, what we'll do is we'll connect up this on switch quickly. So as I mentioned, we like to use these on switches that we get. I'm actually going to pass it through the back here, which will work pretty well. And it's pretty simple. I've made a very elementary little bracket here for it to sit in. It's just a case of pushing through the bracket, popping the spring washer and the nut over the top of it there. We'll turn the battery outside like this, and I'll show you where it goes in here. So your on switch is going to wrap around the bottom like this, and it is going to go into that hole there. I tend to take a little flat screwdriver and just push it in, make sure that it's in. Obviously do that with care so you don't actually damage the cables, but that's basically your on switch sorted there. Then I just tuck the cables in nicely out of the way. Okay, I'm gonna spin this around so that we can see the other side of the Daly BMS here. Now we're going to connect up our temperature probe. So that is this thing here. Pretty straightforward. Again, it's similar to the other. You put it into the slot that says NTC, and so I just check. It can only go one way. You just need to line it up. It's pretty straightforward. It goes in, clicks, and then I usually just would put it into the hole that I've made there and put it into here somewhere. Just wrap it around. Maybe put it under one of the bus bars just to, it can just sit there doing its thing. And then lastly, before we actually turn it on, is the Bluetooth module. So the Bluetooth goes into this slot here that says UART, and again, it can only go one way. So in this instance, the it's got two little things sticking out on the side there. When you look at it, it can only go one way, so those things basically need to stick out away from the BMS. And again, I just take the little flat screwdriver that I have and push that in until it clicks. Make sure that it's seated nicely, and obviously taking care not to actually damage the wires themselves. And then finally, now that everything's connected, we can actually connect our balance leads and turn things on. So I'm just going to check the voltage here, but when I connect these up here, it's saying just over 3 volts, which shows me that the BMS is off. And so if I take that and plug the balance leads in there, again, this plug can only go one way, so that's those plugged in there. And then if we hit our on switch here just once and check it, we should have turned the BMS on. I'm just going to put that there and we'll check it. Okay, so now that we have a battery completed here, everything's good to go. The Daly BMS is connected up. The only thing that I would probably do in terms of building out this battery some more would be to put a positive cable coming out of this hole here on this side onto the positive terminal, and then that go to a fuse or something along those lines. But I just thought I would take you through the actual Daly BMS app to talk you through what settings I have on this. So I'm just going to change this here quickly and I will demonstrate. So this is what the app looks like over here. So it has a little green icon. It's called the Smart BMS app, and when you go into it, it pops up with a screen like that where you should be able to see your device. You don't have to connect to the Bluetooth device in your actual phone settings. So you just open the app and you should see it here. Sometimes the BMS will go to sleep, in which case you just need to turn the on button on or connect bridge those two pins in that port that I showed you before. When you click on that, it'll open up your app, take a while to load. We can see here 100% state of charge, gives you the sum volume, so 14.5 volts. There's currently no draw going from it and no charge to it. You can see the charge management is turned off because it's a full state of charge, and it's not currently balancing because it's just idle. And you can see various valuable information like your delta between the cells, a little bit higher than I would like on that delta, but it's not too bad. We can deal with that. And then you can see your voltages here. In terms of the preferences, this is sometimes what Daly gets a bad name for, is because the preferences that come with the device are not great. So that is these settings here. So I've updated this BMS to my preference of the settings that I like. So I just thought I'd run through it. your cell voltage high protect. So I like it at 3.6 volts. Some people will take it to 3.65 or 3.7 volts, but I like it at 3.6 volts. It gives you good safety to not overcharge your batteries. They'll last slightly longer, etc. Cell voltage low protect, I set that at 2.5. Some high protect, I put it at 14.4 volts. So it's slightly above that just from balancing the cells, but it'll settle down, and from now on the BMS, when I charge the battery now, the BMS will make sure that it doesn't go over 14.4 volts. Some volt low protect 10 volts. Some guys like to have this higher so that your battery cells last a bit longer, that sort of thing. So you can adjust that if you want to, but definitely don't go below 10. Cell volt diff protect, I don't change that, I leave that at default. Charge over current protect 300 amps. The BMS is 200 amps, so I'm not sure exactly what that does, but I've never even drawn a BMS more than probably 160 or 170 amps anyway. If we scroll across here, you just set your capacity of your cells, so I put there 102 amp hours. Cell reference volt 3.2, so that's just the nominal voltage that the cells would come at, which is about that, and then the rest of the stuff I just leave as default. And then here, all of this stuff I just leave that as default. I don't know exactly what all of this stuff does. I've not read up on the manual on what that does. This is one of the areas where Daly really falls short, is the temperature setting. So charge high temp protect, I set that to 45 degrees Celsius, just because I don't really, I pretty much won't ever be in temperatures above 45 degrees because I'm mostly in the UK and Northern Europe. I might get down to sort of Portugal, Spain, and maybe Morocco over the next few years is potentially on the cards, and at that point it may cut out and not actually charge if you go over 45 degrees, but I'm happy with that. It doesn't really matter your high charge temp protect if you're not going to be in high temperature environments. Charge low temp protect, that's the important one. So I set that at 2 degrees Celsius, but essentially you do not want to charge your battery below 0 degrees. So below freezing, you do not want to go below that when you're charging. Discharge high temp protect, I set that as 50 degrees. Again, I'm pretty much not going to be in a situation where it's over that and I'm drawing from the battery. Discharge low temp protect minus 20 degrees. It's highly unlikely that I would be in that sort of temperature with this rig and with this battery, so that's what I would set that to. Obviously, if you live somewhere like Colorado or somewhere where you do really get cold temperatures, then you would have to adjust these and really look up at the manual as to what they mean and what the BMS will do. And then this stuff, I just leave that on. This is just your controls for turning it back on and stuff. But yeah, that's basically the settings that I would have in my Daly Smart BMS. So yeah, that's us. I hope this video has been helpful for you in setting up your Daly BMS on your battery cells. If you have any questions, I'd love you to leave a comment down below. But yeah, thanks for watching, and we'll see you in the next video.